Good day, friends. Today I want us to solve some questions that have to do with energy. The first question here says that a 2 kg object is lifted 3 meters above the ground. Calculate the gain in gravitational potential energy. So, for solving gravitational potential energy, let me say G, gravitational potential energy. The equation for it is the mass times the gravitational field strength times the height. So in questions like this, most times they ask you to take G to be equal to 9.8 meter per second squared. So just plug into this equation. Gravitational potential energy is the mass, which is 2, multiplied by the gravitational field strength, which is 9.8, multiplied by the height, which is 3. So if you multiply all of this together, you get a gravitational potential energy of 58.8 joule. All right, we'll go on to the next question. Question 2 says a car of mass 1,200 kg is moving at 15 meters per second. Calculate its kinetic energy. So solving for kinetic energy, if you look at your equation sheet, you see equation like this. E of k is equal to half mv squared. Or you can see equation like E of k is equal to 0.5 mv squared. So half here is the same as 0.5. So any one of the equation you use, you will arrive at the same answer. So put our parameters into this equation. E of k is equal to half multiplied by the mass, which is 1,200, multiplied by the velocity, which is 15 squared. And after solving this, you get E of k to be equal to half multiplied by 1,200, multiplied by 15 squared is 225. And if you punch all of this into your calculator, you're going to get this to be equal to 135,000 joule. Or if you're putting this in standard form, it's going to be 1.35. You shift your decimal point to the middle, times the number of times you shifted it, which is 5 times. That's 10 to the power of 5 joule. So this is the answer to the question. As we go on to the next question, it says, a kettle transfers 300 kilojoule of energy in 2 minutes. Calculate its power. I want you for some second, pause the video and solve yourself. All right, so let's solve together. It says a kettle, the question says a kettle transfers 300 kilojoule of energy in 2 minutes. Calculate its power. So the energy is equal to 300 kilojoule. And this is the same as 300,000. Kilojoule is multiplied by 1,000. The time here is 2 minutes. And you multiply 2 by 60, that's going to be 120 seconds. So the energy, or sorry, the power is equal to energy divided by time. Energy here is going to be 300,000 divided by 120. When you divide 300 by 120, it's going to give you 2,500. Power is in watts. So this is the answer to the question. Go on to the next question. It says calculate the efficiency of a lamp that transfers 60 watts of useful energy from 200 joules supply, sorry. So the efficiency, look at your equation sheet, efficiency is equal to useful energy output, divided by energy input. So from the question, they said it transfers 60 joule of useful energy. So the useful energy is 60, and the output is, sorry, the input is 200. So you multiply this by 100%, multiply by 100. So this gives 0.3 multiplied by 100%. This gives 30%. So efficiency of a system is always less than 100%. There's no system that produces an efficiency of 100%. So if you're getting anything above 100%, know the answer you got is not correct. So it's supposed to be below. The closest it can be is 99.9, but it can't be 100%. So that is it for that question. So from the knowledge we used, from knowledge gained in solving the previous question, you can attempt this one. Here's a brain teaser. It says a student uses 100 joule to push a box 5 meters with a force of 20 Newton. What percentage of the work was wasted as heat? So solve this one and put your answer in the comment section. Thank you.